everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST, which has been the computer-based numerical and statistical technique. This has been the class's 37th class, which we have to talk about it, and that has been the important one, of course. In the same way, in computer-based numerical and statistical technique, we had done your unit 1, which has been the computer arithmetic errors and rules of equation, where that we had completed. We had done bisection method, second method, and Newton-Raphson method. Many more we had done. And in today's unit 2, which we had started even though in the last classes, which has been the interpolations and curve fitting, which we have to discuss, and that has been the important one. So we'll continue further this, but before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many maximum people can get the information at once, and even though you can also enjoy the video as well. So here we go. Explain a gram schema's orthogonizing process to obtain the orthogonal polynomial. For the same, we have to talk about it. Explain gram schema orthogonalizing process to obtain orthogonal polynomial, and for the same we have to go ahead. So for the same here, that the gram schema's polynomial that over the interval a comma b that to be are given in the following equation, and that will form it. It will be p0 x is equals to 1 always, and p1 x is equals to x minus a 10, p0 x equals to x minus a10 here, and for the same a10 equals to a, and this has been b x w x dx upon a and b w x dx. So for that it will be p2x is equals to x square minus a20 p0x minus a21 p1x. So and for that it will be equals to x0 x square minus a20 minus a21 b1x here, that we have performed as well, and that has been the important one. So here wx is the weight function, so for that it will be a20 equals to b and a x square wx dx whole upon a and b wx dx, and a21 is equals to b and a x square. For that wx p1 x dx whole upon a and b wx p1 square x dx that we have. So here you have to know that p0x and p1x and p2x are all orthogonal to each other over an interval a comma b. So we get a and b wx p2x and p0x dx is equals to 0. For the same wx p2x p1x dx equals to 0. For the generalized equation we talk about here, and that we have for the same for the generalized equation here that has been your pix equals to xi minus ai0 minus ai1 p1x minus ai2 p2x minus aij pjx that we have. So here ai and j, that is j equals to 0 1 and I minus 1, that are the constants to be determined. So and aij equals to a, and this has been b, xi w x p j x dx, and here b w x p I pj square x dx. So here j equals to 0 1 till I minus 1, and now we go ahead further, which we'll talk about it, and that will be the another question. Obtain the first three orthogonal polynomial p0x, p1x and p2x in an interval 0, 1 and with wx equals to 1 here. So using this Gram-Schmidt's orthogonalization for process as well. So for the same we go ahead. Obtain the first three orthogonal polynomial p0x, p1x and p2x in an interval 0, 1 with wx equals to 1 using Gram-Schmidt orthogonalization process. So for that we have to solve it out here, and we go ahead. Here p0 x equals to 1, so a10 equals to a and b, which is xw x dx upon b and a, and for the same here wx dx equals to 0 1 x dx upon 0 1 dx, which is equals to x square upon 2 1 and 0 whole upon x 0 and 1, so which has been equals to 1 upon 2. So p1x, for p1x equals to x minus a10, which is equals to x minus 1 by 2. For a20 we go a and b, x square wx dx upon a and b wx dx. It will further solve it out. It will be 0 and 1 x square dx upon 0 1 dx. So it will be x cube upon 3 x 0 and 1 to get your value 1 by 3. Now for a21 here, which we have to go ahead, which is being a and b x square wx d1x dx whole upon a and b wx p1 square x dx equals to 0 1 x square x minus 1 by 2 dx upon 0 1 x minus 1 by 2 square dx equals to 1, that we have now. So for the same we go ahead further, and that has been the another question, and which further we'll solve it out this, and then after that we'll find it out then another question, and that what we'll have to solve it out here. So here we go ahead. That has been p2x equals to x square minus 820 minus 821, that we have of p1 x, it will give you x square minus 1 by 3 minus x minus 1 by 2, which will give you x square minus x plus 1 by 6, that we get as an answer for this type of a question. Now we go ahead for the another question, that the question is state Chebyshev's polynomial and the important properties. For the same we have to talk about it. So here we go ahead. State Chebyshev polynomial and their important properties. So Chebyshev's polynomial of the first kind of that have been given here is your tnx equals to cos n cos inverse x. Chebyshev's polynomials that satisfy following the recurrence equation, we get tn plus 1 x equals to 2x tn x minus tn minus 1 x here. So where with t0 is equals to t0x equals to 1 and t1x equals to x. So sum of the polynomial that has been listed here is being t0x equals to 1, t1x equals to x, then t2x equals to 2x square minus 1, and then t3x is equals to 4x cube minus 3x, and t4x is equals to 8x4 minus 8x square plus 1. So hence we can write it down here, and that has been in the form. So for the same it will be equals to 1 equals to t naught x, where x equals to t1x, and x square is equals to 1 by 2 t2x plus t0x, so x cube equals to so for the same we go ahead, and that has been x cube equals to 1 upon 4 t3x, that we have plus 3t1x, that we have for the x cube. Now the further we go ahead further, we'll find out for the x4 equals to 1 upon 8 t4x plus 4 t2x plus 3 t0x, and for that properties we have here is as follows, like that tnx is a polynomial of the degree n, where t and x is even if n is even, and it is odd if n is odd. T and x is less than equals to 1 in the interval of -1, x and 1, and where the t and x is orthogonal for the weight function, which is wx is equals to we have here that is being equals to 1 upon under root 1 minus x square. So now we go ahead to discuss about explain the Chebyshev's polynomial approximation, that what we have to discuss here in the detail about it. So for example, that you have to consider the function that is being the continuous over an interval that is of a comma b, and let this function be the approximated by the polynomial, which is p n x is equals to c naught c1x plus c2 x square plus till cn x xn. So then an error in approximation is to be given as like we have your a of x is equals to fx minus p n fx, that the value of c0, c1, c2 and cn that are being obtained such as an error that satisfies the following equation as well. So let the point lies in the interval x0 is equals to a and xn plus 1 be equals to b, and then x0 is less than x1 and x1 is less than x2, x2 is less than x3 till xn and xn minus x plus 1. In the other word, x1, x2, x3, xn that are lying in the interval a comma b, and there are the least n plus 2 points where that is satisfied. Now we go ahead for the next question that we discussed about it, which is of course being the important one here, and that is here we go ahead. Determine Chebyshev's linear approximation to the function fx is equals to x cube in an interval 0 comma 1. So here the linear approximation, that means n is equals to 1 and p and x is hence approximated the function. So where for that it will be p1x is equals to c0 plus c1x. So the interval a comma b equals to 0 comma 1, and hence x0 is equals to a, which is equals to 0, and x2 is equals to b, which is equals to 1. So let x1 is equals to alpha and some points such that a x1 is less than greater than a and less than b. So for that condition it will be fx minus p1x, it will be equal to x cube minus c0 plus c1x, x cube minus c0 minus c1x. We know that x1 xi equals to xi plus 1, x0 equals to minus x1, p0 equals to alpha. Since x0 is equals to 0 and x1 equals to alpha, so since p alpha is equals to 0, similarly x1 equals to minus x2 alpha equals to minus 1, since x1 equals to alpha and x2 equals to 1, and since alpha plus 1 equals to 0, for that e dash x equals to 3x square minus c1 equals to 0, and here x equals to alpha and 3 alpha square minus c1 equals to 0. You have to put the value x0 and x equals to alpha in an equation. We get plus alpha cube minus c0 minus c1 alpha equals to alpha cube minus alpha c1 minus 2 c naught equals to 0. So putting x equals to alpha, x equals to 1 in the equation, we get alpha plus 1 equals to alpha cube minus c0 minus c1, alpha plus 1 minus c0 minus c1 equals to a cube minus alpha plus 1 c1 minus 2 c0 plus 1 equals to 0. So for solving the equation here, we will be getting here is c1 equals to 1, alpha equals to 1 upon under root 3, and c0 equals to minus 1 3 under root 3. So for hence Chebyshev's approximation becomes here is p1x equals to c0 plus c1x, that will give you minus 1 upon 3 under root 3 plus x is equals to x minus 1 upon 3 under root 3. So now let's go ahead with our next one, which has been another important question, and that we will have to discuss here is been explain the Langkos economization of the power series. So explain a Langkos economization of the power series, we talk about it, and that what we'll have to discuss here. So the function fx that can be expressed with the help of Chebyshev series equation expansion, that to be as follows here. And so for that equals to a naught upon 2 plus a1 t1x plus a2 t2x plus a3 t3x plus del an tnx plus an plus 1 tn plus 1x plus remainder. So here tnx is been are the Chebyshev's polynomial. Now neglecting the remainders above equation, we can be written, that can be written as in the form of fx minus a naught upon 2 plus n I equals to 1 a1 tix equals to a n plus 1 tn plus 1 x. For that the term a n plus 1 and tn plus 1 x has n plus 2 equal maxima and minima that alternates in sign. Then by Chebyshev's equi-oscillations theorem, the term in the square bracket is the best approximation to fx. That is, we have p n x equals to a naught upon 2 plus n I equals to 1 ai tix. So this has been the approximating polynomial for fx. Now we go ahead for the next, we talk about it, that is been the another important question here, that what we'll have to discuss here. But here we're gonna end up with, because when we'll go ahead further, which will be taking moreover that has been extended here, and that what we'll have to discuss for moreover further. So that we'll discuss in the next coming class, that is being the 38th class of the session of CBNST. After talking about that, yes, other than that of CBNST, we had done your reasoning. In that we had done verbal reasoning. In verbal reasoning, we had done general mental ability, logic reasoning, and we had done in non-verbal reasoning, we had done series, analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completion of incomplete pattern, figure matrix, paper folding, paper cutting, group detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation analysis, and practice question set as well. In terms of it, we had done your ER diagram, we had even though done your that is in English vocabulary, PHP interview questions as well. We are dealing with GK important facts and your that has been about the country as well. And we had done your chemistry for class 11th and for class 12th part 1. Within that we had done unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9. And even though we had done your conversions, logarithms, anti-logs, and other than that we talk about it. So yes, we had done many more. We had to cover up the chemistry part 2 for class 11, that will surely be starting soon. And for part physics part 1 for class 11, that we have to start discussing about NCRT as well soon. After talking about that, we are dealing with quantitative aptitude. In that we had started with general mental ability, that has been the arithmetical ability. In that we had done operations in numbers, SCF and LCF of numbers, decimal fractions, simplifications, square roots and cube roots, problems on numbers, problems on ages, odds and indices, percentage and profits and loss. That has been we are dealing with 11th topic and surely been completing soon as well. Coming towards computer-based numerical statistical technique, which has been the CBNST. Here we had end up with unit 1, which is computer arithmetic errors. We had completed the floating point arithmetic machine, absecant rounds of error, chopping error, truncation error, associative and distributive law of a floating point arithmetic, inherent error, error propagation, numerical stability, and roots of equation. We had done second method, Newton-Raphson method, and a fixed point iteration method for a simple roots and derivation of their rate of the convergence, adding and accelerations of the convergence, modified Newton-Raphson method to the multiple roots, Birch-White method for polynomial, Weierstrass method for quadratic fraction, and computer algorithm of these methods as well. In unit 2, we have to cover up the interpolations and cooperating, where we have to cover up the algorithm and the error analysis of Lagrangian and Newton's divided differences, interpolations, relationship in the various differences operator, piecewise linear interpolation, cubic spline interpolation, natural splines, Chebyshev's polynomial approximation, Langkow's economization of the power series. In cooperating, we have to cover up that is the linear and non-linear least square approximation. Third, conditioning in the least square method. Gram-Schmidt's process of orthogonalization, computer algorithm of the least square cooperating. In unit 3rd, we have to cover up the differentiation and integration. In that we have to cover up that is the method based on interpolations and finite differences, Richardson extrapolation and integration, the error analysis of the proposital, and your Simpson method, Newton Cotes integration method, Gaussian integration method, Gauss-Lagrange method, Lobato integration method, and Radau integration method, error terms in pertaining to the integration method as well. Coming towards solutions of the simultaneous linear algebraic equation, we have to cover the Gauss elimination method, condition system, condition number, successive and relaxive method, rate of conversion, and solutions of ordinary differential equation. We have to cover up single step method, Runge-Kutta, second order, third order, and a fourth order method, multi-step method, predicator corrector method, statistical hypothesis technique. We have to cover up. There has been the statistical hypothesis, test of hypothesis, type 1 and type 2 errors, level of significance test involving the normal distribution as well. So here we're gonna end up with, and it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many maximum people can get the information at once, and whether you can also enjoy the video as well. And as many as you supported us, thanks to all of you, because your support is very important towards it. Those who had requested for the UR diagram recently, I will be surely providing you within coming 2 to 3 days. And after that, please support us, that what I requested to all of you, because your support is very important to us. Thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.